Hello, grade 9s. Today we're going to just go through how you would factorize an expression that has the form of a difference of two squares. A difference of two squares is a expression with two terms that are both perfect squares, and between those two terms you have a minus sign. So actually you're finding the difference of two squares. Okay, that's where the name comes from. I've already completed the first one. Okay, we know that this expression comes from the multiplication of two binomials where they have the same terms, but the sign in the middle is different. Okay, and you know from multiplying this that you'll get two terms that will then be additive inverses of each other, which means that if you add them, you get 0, and you're just left with x squared minus 25. Okay, so that is in your notes. You will see that. So let's quickly see, how would we factorize? Now, when you factorize, you use the square root to determine what the terms in the brackets will be. So over here, I'll have two brackets if I factorize this expression. And in my two brackets, I will put the square root of y squared, just like I put the square root of x squared there. And that will be y and y. And now 49 is also a perfect square. 49 is 7 squared. So the square root of 49, 7. Now it doesn't matter where you put the plus minus. Remember, multiplication is commutative, which means that you can multiply in any order, it's still the same answer. So if that's minus and plus, it doesn't matter. You can put the plus sign first or the minus sign first, okay? Right. Sometimes you can take out a common factor. Now, when you see terms where you can maybe take out a common factor, you need to check. Okay, so 4 and 81. Do they have a common factor? Actually, no, they don't. But you do know that 4 and 81 are both perfect squares. And you can factorize this as well because that's a difference between two squares. I know that this comes from two brackets. And the terms that go inside the bracket, I need to find the perfect square, or I need to find the square root of these perfect squares. Okay? So that's going to be, what's the square root of 4? The square root of 4 is 2. But this is 4x squared. So that would be 2x. Now 2x multiplied by 2x would give me 4x squared. Okay? That 81 square root is, yes, 9. So put the 9 in there. And now you can put the plus minus. It doesn't matter which order. Okay? Right, let's look at this example. In this example here, I've got 2x squared and 50a squared. Right. The 2 and the 50, there's a common factor of 2. So I can say, let's first take out the common factor. And what I'll be left with is x squared. What's 50 divided by 2? It's 25. 25a squared. Right, but this here is now a difference between two squares. So I'm going to factorize this. It's going to be 2. It's going to be x and x. The square root of 25a squared is 5a and 5a. We can say plus and minus. Okay, and that's it for that one. Right. Now these two over here, they've got something slightly different. So when we have a perfect square in terms of our variables, we need to think about what are our options, right? That if I've got x times by x, then that gives me x squared. If I have x squared multiplied by x squared, so that means x squared squared, then I have x to the power of 4. Okay? But if I have x to the power of 3 multiplied by x to the power of 3, that is x cubed squared, then I'll have x to the power of 6. Now, if I continue this, I will have all my perfect squares squares for variables will be multiples of 2, which means that the exponent will be multiples of 2. For example, x squared is x. The square root of x squared is x. The square root of x to the power of 4 is x squared. And the square root of x to the power of 6 is x cubed. What would be the square root of x to the power of 8? X to the power of 4. Okay, so you get the idea. Right, now I've got b to the power of 6 minus 16x squared. Right, what is b to the power of 6, the square root of b to the power of 6? That would be, okay, b to the power of 3. Because b to the power of 3 times b to the power of 3 is b to the power of 6. Okay. Right, so let's look at this. We've got 16x squared, so that's going to be 4x and 4x plus and minus. Right? Let's look at this one. If it's x to the power of 10, what would be your square root of x to the power of 10? That would be x to the power of 5. X to the power of 5. Okay, so if you ever notice, even powers of a variable would be a perfect square. And in order to take the square root of that, you see that we're dividing the exponent by 2. Okay, and that's how you find the square root. Right, and the last one is the fraction here, 4 over 81. We know that we can find the square root of a fraction. It's just the square root of the numerator over the square root of the denominator. So that gives me minus 2 over 9 and plus 2 over 9. And there you go. Okay, so good luck.